animations that are a bit heavy. So this is very much a collaboration that I'm presenting. I'm currently, or actually I've been here for quite a long time at Royal Holloway, University of London, but recently back from almost a 5-year secondment as the director of the Finnish Institute at Athens. And we have collaborated for a long time with the University of Leiden, with Anne Brysbaert, and her project, actually even the initial of setting up the project set in stone, which currently has ERC funding until 2020. Yes, and as part of the goals of the Finnish Institute, we realized at the Institute that there were not enough people coming from the Finnish universities who had enough of experience in 3D documentation to be useful for the archaeological projects. And as part of that, and also the goals of the ERC project was to train postdocs and PhD students in 3D documentation in a way that they could actually carry out in their own projects within 2 weeks. So that was the finance we had from a private donation in Finland, that we had to do it in 2 weeks, and that also fitted the ERC basically available funds for that part of the project. So I'm going to quickly just go through that, what we teach within those 2 weeks. So basically try to get enough of repetitions on the total stations so that the students, when they go back by themselves, that they can actually operate the instruments, and also then integrating that data with photogrammetry. So I'm first just going to go through this is already sort of a 12-year-old method that's how you can kick as much as you can out of the total station. So basically using that as a drawing tool. And here you see that what's one of the initial goals that started setting that a human brain does have a tendency to see regularities, even if you're very, very skillful in drawing to the 3D objects. As you see, the top is a brilliant architectural illustrator, and her view of what the block looks like, and the below one is then the published drawing that's actually directly derived from the 3D documentation. There's a slight discrepancy between the two. So first one is that you have a limited number of measurements you can make by hand, and when you can actually increase that by doing the line drawings with the total stations. So the basic is that you need to be able to move around your total station and then use laser, not a single time that you would be using the prism. So you will always then have a good reflection from the surface that you're dealing with. And it's actually a very fast way of drawing the line drawings. And as long as we are in the current situation, that line drawings are important. So I think that this is one good approach of doing it. I haven't actually come across yet that's if anybody actually has very good algorithms for creating the 2D drawings from the 3D data, I'd be very happy, because we actually have 3D drawings, and we have photogrammetry and even 3D scans. So if somebody wants to test in a situation that you have a brilliant 3D line drawings, I'd be very happy to hear. We'd be very happy to hear that of the experiences. Okay, so what it means that you need to have a network of fixed points that you can actually move those stations wherever you need them to be. This is one of the examples from 2007. That what you can do with it. This is actually basically a raw dump of the total station data, what it looks like. So drawing it did take a couple of days to in the end do all of the documentation of these particular blocks, and then that's the final published drawing, and that's basically 90% directly done from the total station documentation, and then just slightly enhanced for the tool marks in the 2D program. And as part of when I started the Finnish Institute with the private donation, there is now a Windows console program that actually links directly the total station data to any CAD program. And I haven't actually made it publicly available because there's still a couple of bugs in the program. So, but it's still perfectly usable. But explaining away those bugs and how you get around them would be a bit difficult one. So I haven't done it yet. I actually. I did the first algorithms. I had a very slow script program for that, and my brother did the fast Windows console program, and I haven't gotten around to finishing it yet. So it's on its way. And then I'll take you through the 2 case studies that we've done in the field. So first one, 14 and 15 Tunes, and then 16, 17, a new project that starting on the island of Salamis. And as part of the Setting the Stone project, it actually we've collaborated with quite a few different institutions, and this is the slide that's actually we haven't named there, is the University of Bordeaux-Montaigne, and they had very good specialty in object scanning using structured light. But what we did then was the basically line drawing of the remains. So there is a research goal behind this. So not only just training the students, Anne's project needed 3D data for the econometrics of the citadels and also the tombs. So that was a research goal of all the documentation, and this I think is in midway of the second season that we basically documented stone by stone the visible remains on the eastern half of the citadel, and 16 setting up the field school at Salamis. What we actually have been doing that's some of the instruments that we're using are new, so there's been a bit of a budget. Some of them are second-hand, some of them are borrowed, and basically the aim was that at least there would be half a dozen of total stations for the drawing, so that the drawing would proceed quickly, and also that the laser would be strong enough to be seen in the midday sun in the Greek environments. And as a typical student task, so we're dealing with the a bit old-fashioned way of excavating, so 4 by 4 meters trenches with a 1 meter bulk in between, and the excavations were never completed. So it was done by the efforts in 2004, 2006, and we collaborated with the efforts to get the final drawings out of the site. And then each of the students would have a task of, this is actually a very simple one of the most simple one of the trenches that's doing both the line drawing and then the photogrammetry of the trenches. And this is what it looks like. Oops, let's take it back. So just the photogrammetry of the trench, and this is the students documenting it from sort of about 30 drawings. Actually, Daniel Turnell, who was this one, so he's currently finishing a PhD student at Leiden, and also then doing the drawing of the you see that it's actually not a completed drawing yet, this one, so that but anyway, getting the major lines out of it. And if we go, what we managed to do over the 2 seasons, 16, 17, so actually 4 weeks of work together, there are about 5 different parts that we have documented stone by stone. The old excavations that are still visible, so they're in yellow and red, and I'll just show this part here, what it actually looks like in the final documentation. So that's the combining the photogrammetry with the line drawings of the site. So that's what we basically have done encoding overloaded. So that's okay. So that's what you can actually document fairly quickly in this method. So we have both the photogrammetry and then we have the line drawings that we can do all the sections, the 2D plans that are necessary.